Hi, this is 10.1 lecture video C. We are going to we're going to complete or finish up our 10.1, and we are going to graph each function and define with radicals. So, and give its domain and range. So first of all, we have f of x equals the square root of x plus 2. What we're going to do is we're going to go y equals the square root of x plus 2. This is a function. Y is just f of x. You're going to create points. Every time we're going to plug in whatever the x value they give you, you are going to plug it into this equation. Now I'll do a couple of them and then we will do them just in our head. So first of all, my first x value is -2. If I put a -2 in here, I get this the square root of -2 plus 2, which is 0. The square root of 0 is 0. So my very first point is -2, 0. Now my second point is -1. If I put -1 in for x, -1 plus 2 is 1. The square root of 1 is 1. So my second point is -1, 1. Now, if I put in 0 for x, I get the square root of 2. So, and I can't reduce the square root of 2. I can use a calculator. And when I use a calculator, it's about 4.1 something. So I'm just going to say, I'm sorry, it's going to be 1.4 something. Now, if I plug in 2 for x, 2 plus 2 is 4. So the square root of 4 is 2. Okay? So now I have this point and I have this point. Now I'm going to graph them. I start at the origin. I go over -2 and I stay there. My next point is -1, +1, 0, 1 and a 0.4. So that's about right there. It's not perfect, just did the best I can. The next one, we go back to the origin. We go over 2, up 2. Now, because it's like my parent function from earlier, when I did a square root, it started at the origin and it moved over. Now that was for the square root of x. My problem was x plus 2. And if you noticed, it would have normally started at 0 and went in this direction, but because it had a plus 2, we moved to the left and it goes in that direction. All right? So in order to find the domain is your x values. If you notice, it stops at -2. -2 is part of the solution. So that's going to be -2. Now on the x-axis, if you notice, it keeps on going to the positive infinity side. So that's going to be a positive infinity, and that's a parenthesis because it continues. It doesn't stop. And infinity goes on forever. Now the range starts at 0. This is the range. This is the y-axis, and it starts here at 0. So it starts at 0, and 0 is part of the range. However, it also goes upward. So if you notice, as this is going, the y values are increasing. So it's going towards the positive y-axis. And that looks like that. So there's your range and your domain. Let's do the next one. The next one is a cube root. So once again, we have y equals the cube root of x minus 1. I'll do a little example over here. We have the cube root. Whoops, let me do this timer so I know when to stop. All right, the cube root of x minus 1. Highly recommend you do that. We're going to plug in numbers. I'm going to put in -7 here. So I get the cube root of -7 plus a -1 is a -8. I know that the cube root of -2 to the third power is -8. Now, because these are odd numbers, I know that my answer is going to be a -2. So I'm going to go ahead and put -2 right here. So my very first point is -7, -2. Now I'm going to plug in 0 here. And I end up with, let me do that one more time, just to kind of go over it. I don't know if I'm going to use that one. All right, so I'm going to put in 0, which gives me a -1. Now I can rewrite this problem as -1 to the third power. -1 times -1 is 1. 1 times -1 is a -1. So I can just put a 3 there, and I know it's going to give me -1. So the cube root of -1 to the third is just -1. So this is going to be -1 here. So my second point is 0, -1. Now my third point, if I put a 1 in here, 1 minus 1 is 0. The cube root of 0 is just 0. So that is my third point. The next one, I'm going to put in 2 here. 2 minus 1 is 1. The cube root of 1 is just 1. So that is my fourth point. There are many more points, but that's all we need to work with. So I'm going to graph this. I'm actually going to extend this just a little bit more. I'm going to say that's a -6 and a -7. So my first point is -7 and then down 2. The other one's going to be 0, -1. The other one's going to be 1, 0. And then 2, 1. Now, just like my parent function for a cube root, if you notice, it was a cube root of x. It started at 0, and then it started moving that direction, and then it started moving this direction. Now this time, because of it, I have an x minus 1. It actually gets shifted over to the 1 over here. It gets shifted to the right. It's a little bit different. If this was a positive 1, it would have been over here at the -1. So basically it's telling you that 1 minus 1 is 0. Okay, so my graph is going to look like, I forgot. No, I did it. Yes. So this is going to look like this. And like this. All right, so that is your graph. Now, if you notice, this is a negative infinity. This is a positive infinity. This is a positive infinity on the y-axis. This is a negative infinity on the y-axis. So the domain goes on forever towards the negative infinity, and it goes on forever here towards the positive infinity. So that's what that one's going to be. My range goes eventually upward to the positive infinity, and then it goes down to the negative infinity. So it's going to be the same concept. All right, that's it for that one. Take a look at the other two graphs prior. Now we're going to talk about nth roots and nth powers. Now remember, when you take the square root of something that is squared, it's going to give you, because that square root is even, and it's to the even power, which means you're going to take the absolute value of your answer. So you'll see what I'm talking about in a few minutes. However, there is something else you have to know. If you have an odd positive integer, then, so n is an odd positive, so let's just say this is a cube root, and that's a cube. Well, whatever a is, positive or negative, it's going to be whatever it happens to be. And once again, I'll show you what that means in a few minutes. All right, so let's go back to this. First of all, you have a square root, which means whatever's being squared comes out. So that's going to be 15. If you remembered from back in the day, 225 is 15. All right, 15 times 15 is 225. Now here's something that's tricky. This is what I was telling you about. There is really an imaginary 2 right there. Whenever you have a square root, you know there's a 2 there. So normally what you do is, this is a square root and something's being squared. So whatever's being squared comes out. This one's a little different because it's an even index. And this is an even power. You have to take the absolute value of -12, and that's going to give you 12. So there's a little bit of different rules on that aspect. Now on this one, you're going to actually get y. You have to take the absolute value of y, but it's just y, not a big deal. I mean, it's the same idea here. I'd be taking the absolute value of 15. It's just 15, not a big deal. Now for this one, remember this is a square root, so it's an even index and an even power. So that's going to be the absolute value of negative y, which is y. Okay? And we'll go over it more later on. All right, so let me go across to these ones. These are the fourth roots. If you notice, that is an even number, and that is an even number. So when you have an even index and an even power, you do have to take the absolute value of this. So I'm going to show you what I'm doing. I'm taking the absolute value of it, and I get 5. For some reason, I keep thinking I didn't put it. No, I did. Okay. Now on this one, these are odd index, odd power. So on this one, you can say it's negative 5, not a big deal whatsoever. Now letter C is totally different. There is a negative number on the outside of the radical, so you don't touch that. Now, because this is an even index and this is an even power, whatever's inside here comes out, but you've got to take the absolute value of it. Now remember, the negative on the outside of it is a -1 all by itself. So that's going to give you a negative. And the absolute value of -3 is 3. And then that alone is going to give you -3. I hope that's okay. I tried to write it out as much as I possibly could. Now the next problem, I have a negative. I have a fourth root, which is the 4 is the index, 8 is my power. Those two numbers are not the same. I need to make them the same. So what I'm going to do is I'm going to break this up, and I'm going to use the rules for powers. Now m to the second power raised to the fourth power. Now first of all, 2 times 4 is 8. So when you raise a power to a power, so this portion right here is exactly the same thing as this. So what I end up with is my negative is on the outside of the whole problem. Don't even look at the negative, it's on the outside. But I have an even number for the index, and I have an even power. Whatever's inside of here comes out, and that's going to be m squared. Negative times m squared is just a negative m squared because the negative is on the outside portion. Alrighty? So let's keep going, and I'm okay on time. Now we're going to use our calculator to find roots. And let me see how much more I need to go. Otherwise, I think I can get done with this quickly. All right, here we go. First of all, to use the calculator to find these, all I'm going to do is take my calculator, and you can use your calculator. I'm going to turn my calculator sideways. The square root of 17 is 4.123. They want me to do 3 decimal places. This next problem has a negative on the outside of it. So I'm going to do this, okay? So 362, I'm going to take the square root of that. That gives me 19.026. I'm going to multiply it by the negative on the outside. So I end up with negative 19.26. Now on this one, I'm going to take the cube root of it. Your calculators will also do cube roots. So 9,482, and I'm going to type in the cube root, and I get 21.166. It's actually 1657, but the 7 will change the 5 to a 6. Now the next problem, though, I'm going to do the fourth root. So 6,825 to the y square root of x. I'm going to say it's the fourth root, and I'm going to get 9.089. So that is using a calculator. Now let's jump to this problem real quickly. I want to get this video done as fast as I can. So I get 1 over, so I don't go over. So all I'm doing is plugging chugging numbers. So I'm going to take the square root of L is 6 times 10 to the -5th power. times 4 times 10 to the negative 9th power. And back when we were working on first semester scientific notation, this is what we did. So we have F equals 1 over 2 pi. Now I'm going to do the math. I'm going to go ahead and multiply. I know that 24 times 10 to the negative 14th power, that's not what I wanted. Should have done it backwards. 24 times negative 14 x to the y power 10 equals, still should be a decimal. It's not giving it to me. Hang on 1 second. Let me just do this. 24 times, let me just do the negative first. Negative 14 power 10 equals 10, that one, negative 14. There you go. Times it by 24. I'm going to take the square root of that. I get this really huge number. So I get 4.89 times 10. So 1, 2, 3, 4, 5, 6, 7. 10 to the negative 7th power. Because I already square rooted it. That's why I have that number. Now I'm going to take 1 divided by 2 times 3.14 times 4.9 times equals, divide by negative 7. Oops, wrong button. 10. And I have a terrible time putting scientific notation in this calculator. So let me try this one more time. Negative 7, 10, oh, that's not it. 10, negative 7, times it by 4.89, times it by 3.14, times it by 2. I guess that's it. So 1 over, real quickly, it's going to be 3.07 times 10 to the 1, 2, 3, 4, 5, 6, negative 6. All right, and then we're going to just divide that. And I get 325,635 and 31 hundredths. And they want it to the nearest thousand, so that should be 325,000. Actually, it should be 26,000. They want it to the thousands. So if we rounded it, it would be here. Now, hopefully my scientific notation division was okay. This calculator is not the favorite one. If I